All right, let's do section 10.1, page 485, exercise 9, which reads, compute the limit of the partial sums to determine whether the series converges or diverges. And our series is 1/2 plus 1/4 plus 1/8 plus ... plus 1 over 2 to the k plus ... Well, I think if we're going to look at the partial sums, we might want to have a few more terms in here. So what's going to come after 1/8? Well, we're going to have 1/16 or 2 to the 4th. And then what's our next term going to be? Well, we're going to have 1 over 2 to the 5th or 1 over 32. So let's look at these partial sums. So S1, the first partial sum, is just the first term. So that's going to be 1/2. S2, which is the second partial sum, is going to be the first two terms added together, or 1/2 plus 1/4, which gives us what? That's right, 3/4. The third term, S3, or the third partial sum, S3, is going to be the first three terms added together. So that's going to be 1/2 plus 1/4 plus 1/8, which is going to be equal to what? 7/8. The fourth partial sum is going to be the first four terms added together. So that's going to be 1/2 plus 1/4 plus 1/8 plus 1/16, which is going to be equal to what? Yep, 15 over 16. Move this down a little bit. And if we want to do the fifth partial sum, that's going to be the first five terms. So that's going to be 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. And what's that sum going to be? Yes, it's going to be 31 over 32. Now, you may notice a pattern when you look at these partial sums. And we can actually express any partial sum sk as what? Well, if we took S5 down here, for instance, we could see that the sum is really 1 minus 1 over 2 to the k. And remember that for k equals 5, our term is 1 over 32. So 1 minus that is going to be 31 over 32. So one thing that you read about in your book is that if we want to know whether or not the series converges, we could really look at the limit as k goes to infinity of the term for the partial sums. And that will tell us, because this will be the last partial sum, what the series is equal to would be the s infinity term. And so let's substitute in here. So we're going to have the limit as k goes to infinity of 1 minus 1 over 2 to the k. Now 2 to the k is going to go to infinity, which means that 1 over 2 to the k is going to become an extremely small number approaching 0. So that means that this limit is going to be equal to 1. Now, because the sequence of partial sums converges, this tells us that the series itself converges.